Alright, so when we're talking about polynomials that are more than just quadratics, okay, higher degree, we're talking about cubics or quartics or quintics, everything we're talking about also does apply to quadratics, and in fact it even applies to linear functions, okay. There are a couple of things we want to keep in mind. First of all, when we're talking about a polynomial function, the graphs are always smooth and continuous. Okay? Now, how do we know it's a polynomial? Well, we've got x to a power, and that power is greater than or equal to 1. And it's an integer. Okay? We don't have fractional exponents. It's not to a negative power, giving us a rational function. Okay? We have something like x cubed, x to the 5th, x to the 6th, something like that. Okay? Now, one thing we want to do when we're trying to graph these is we want to kind of give ourselves a game plan. You know, what are the steps we can kind of follow to graph a polynomial? First of all, we want to get a general idea of what it's going to look like using our leading coefficient test. Then we want to find the zeros, and then find a couple other points that'll help you get the shape a little bit more accurate. Okay? So, first of all, the leading coefficient test. Alright? First of all, make sure you understand what a leading coefficient is. So let's say I had a function f of x equals 7x to the 5th minus 3x cubed plus 5x squared plus 7x minus 2. Okay? When I'm talking about the leading coefficient, I'm talking about this 7 right here. The term that has the highest power. It doesn't necessarily have to be the first one written down. Okay? But it's going to be the term that has the highest power. 7 is our leading coefficient. Okay? Now, we see here we're talking about two different cases. First of all, when n is odd, and then when n is even. N, in our case, in this case up here, is 5. N is the degree of the polynomial. Okay? It's that highest exponent. Okay? Now, when n is odd and when n is even determines whether the two n's do the same thing or opposite things. Okay? When n is odd, okay, the n's behave differently. If it's going up on one side, it's going down on the other side. Okay? When n is even, think about when everything's even, everything is the same, right? Okay? When n is even, the n's do the same thing. Okay? Now you can see over here on the right hand side I have x to the first power, x cubed, x to the 5th. These are all to odd powers. And you'll see that what's going on the left side is the opposite of what's going on the right side of those functions. So this x, x cubed, and x to the 5th are all going down as we go to the left. They're going up as we go to the right. Okay? With the negative x, negative x cubed, negative x to the 5th, they're going up to the left and down to the right. Okay? So the positive and negative, if you think about it this way, the positive and negative tells us what the right-hand side is going to do. Okay? If the coefficient is positive, like it is in this case, all right, it's a positive 7, then the right-hand side's going to go up. And that's true whether n is even or odd. Doesn't matter. If it's negative, the right-hand side's going to go down. Again, doesn't matter if it's even or odd. It's talking about the right-hand side. Okay? So there's a lot going on this page here, but let's sum this whole thing up. Okay? Odd degree, the ends do the opposite thing. Even degree, the ends do the same thing. The sign of the coefficient tells us what the right side will do. Okay? The sign tells what the right side does. Okay? So you'll notice these ones here, where it's plus, the right side is going up. Plus, right side goes up. Plus, right side goes up. Down here even, plus, right side is going up. Plus, right side is going up. Plus, right side is going up. Okay? All these ones here where we have a negative leading coefficient, the right side is going down. Okay? So then you say, well, how do I know what the left side does? That's where the even and odd comes in. My left side is going to do the opposite thing if n is odd. It's going to do the same thing if n is even. Okay? So, there's a lot going on here in this, in what your book has for this test. But you can break it down into those two steps. Positive or negative, what's the right side doing? Even or odd, tells us what the left side will do. Okay? All right. Now, another thing that we need to be able to do is identify the zeros. And I'm going to kind of work backwards with this. I'm going to start with ones where we know the zeros. Okay? And then we'll work to where we're finding the zeros. All right? Now, there's a couple of different properties of a zero. These are all essentially saying the same thing. Okay? But the thing I want to focus in on here is highlighted. X minus a is a factor of the polynomial. Okay? And a in this case is what the zero is. Okay? So, for example, here I have a function. I want a function that has zeros at 2, 5, and negative 3. Okay? So, if 2 is a 0, then what this is telling me is that x minus 2 is a factor of my function. Right? And since 5 is a 0, what's another factor?
X minus 5.
X minus 5. And what's my last factor? X plus 3. Okay, x minus a negative 3. Okay? So that is a function that has a zeros at 2, 5, and negative 3. Okay? Now you'll notice I use the word a function there. How many functions have those 3 zeros?
N factorial.
N factorial.
Well, just those zeros, or like those zeros and other
Just those zeros.
Or those zeros and one more.
There's one.
Just those zeros.
There's one.
There is
One. It's x to the third minus 4x squared minus 11x plus 30.
Okay.
It's so fun. Math rules.
It's So sketch me, well everyone, sketch a picture of the function that has those zeros,
Oh, man.
right?
30? That's a minus,
Oh, I see this.
Oh, it's about to go down.
No, because we'll have one starting from the bottom of the
Yeah, you're gonna go. But one of your humps is gonna go through 30, right?
No, one's gonna come from top, one from the bottom.
No, it's positive. It's all positive. The x is positive, so it's gonna be. So the right is gonna go up and the left's gonna go down. So left.
I'm not necessarily asking for, as we have it written there, what's f of x. We draw a function that has zeros at 2, 5, and -3.
Only those zeros?
Only those zeros.
We can do.
No extra zeros, just those 3.
This tricks that I got you, man.
I got you.
Okay, so let's see, Neves looks like
But
this.
the first hump should go up to 30. That's
Okay, that's exactly what mine looks like.
Okay, well, if you're using this f of x with a 1 right here, yes, that's correct, it should go up to 30.
I did mine backwards.
Wait, how'd you do yours?
I did it going down.
So you went like this?
Yeah.
Okay, is that possible?
No, the right always has to go up.
Why?
Wait, how do you
Well, what if it was this?
Yeah.
Oh, then you're just
Yeah,
evil,
so-
and that's how you want it to be.
Okay. Well, my point is this, okay? How many different functions have those 3 zeros?
Infinite.
An infinite number, okay? I could have this one that doesn't really go all that high, okay? Or I could have one that goes really high, okay? Like this. Okay? The fact of the matter is there's an infinite number of functions with those zeros, and that's why we put our leading coefficient out here. Okay? After we write all of these factors out, we put a leading coefficient of a there. And a is going to determine which one of those infinite possibilities we want. So if I ask you to write a function, okay, you could have done any of these. If I asked you to write the function with those zeros that hit a specific point, what would you have to do then?
Foil the entire thing and then plug it in.
Plug in what?
Your number, that number into the equals f of x, into the f of x.
Okay, so like if I said I wanted this to hit the point 0, 5,
Then you'd plug it into your entire equation. So you'd foil it and then you put into the x 0 and then 5. And if it doesn't work, then that doesn't. Oh well. No,
well, it'll work, yeah.
Yeah.
Okay, so because the domain and range are all real numbers, so I can make it hit any point I want as long as it's not 2 something else, 5 something else, or -3 something else.
Savage.
Okay.
Why you can do it like that way, like the blue line?
Well, because maybe I have f of x is a -2 times x minus 2 times x minus 5. Okay? It would still have the same 3 zeros. That -2 though is going to make it stretch vertically and go down. Okay? Alright, so here's the thing. How do we get to a function that's all factored out? Well, you have to be able to factor, right?
Yeah.
Okay. So, we have situations where we can factor. Alright? You see things like these over here. Okay? We could factor those different functions. Some of them. But we can just look at a lot of these and figure out which ones are which.
True.
For example, forget about all the equations here and just look at the graphs. A through H. Someone tell me one of the graphs. You don't even know what my question
I
is.
already know, man.
Someone tell me one of the graphs that has an even degree.
C.
Two.
C. 2. We're looking at A through H.
E.
C.
E, G, H. All right, those all have even degrees. Okay? Which obviously means the others have an odd degree. Okay, someone tell me which ones have a positive leading coefficient?
A.
A,
B.
B,
G,
H.
GH.
G, and H? Good. Okay? So you see how that works? You can tell something about the function just by looking at it. Okay? Then if I'm trying to match these up, I can say, okay, well wait a sec. My odd degrees are here, 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 and here. My positive leading coefficients are here, 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 and here. You see how you can figure those out? Because we've got positives on all of these. And right away I can tell a little bit about what that graph is going to look like. Like number 8. It's an odd power and it's got a positive leading coefficient. So I know that on the right side it's going to go up, and on the left side it's going to do the opposite thing. So it's going to be down like that. So
B.
it's going to look something like this. All right, and that does end up being B. Okay. Oh wait, you know what? I circled in green the ones that had odd, and over here I circled the ones that had even, so that's why it's not working out. Okay, but anyways, this one has an odd power and a positive one, so we have B. Okay? All right. So really that's it for right now. We're going to look more at graphing these as we move forward. But being able to write those equations, understand where they're coming from, we're going to practice factoring and factoring by grouping as we move forward as well. Okay? All right.